Hi, one of the viewer asked me if I can show him how to make a cover, the brand logo of the car. Now this logo it's in a chrome color. He asked me if he can make a very thin plastic cover that he can change the color from a chrome color to the black color. This logo may look simple to you, but if you look here, the fixing plane is not flat because the car body has no flat part. It's also curved along this plane. The reverse part has to follow the shape of the car panel. For making a 3D scan, I will just use the Sermoon S1 with the Wi-Fi bridge, connecting to the phone without using the laptop, a magnetic marker, and SKDS2 spray. Create this scan pocket, create this scan. Okay, now scanner is connected. Click on new scan. I use polar lines and the resolution will be 0.2. And this is a Snapdragon 8 Gen 5 phone with a 16 GB of RAM. Start scanning. Have about 34 frames per second. Again, I'm not using the laptop, processing using the mobile phone, so it's very convenient. I don't have to plug in the laptop, boot up the Windows, just snap my phone. I can do a quick scan. Okay, I think that's it. I want you to look at that. Look at the scan result, it's very good, I think. Yeah, I capture everything. Going to import from the phone and export to a computer. Scan the QR code. Now it's exporting. Okay, next I'm going to fill the scan with a 0.2mm. It's very sharp and clean. Okay, next I'm going to crop this into a small area. Click on save. This model is quite difficult to make. The fan blade, it has dual curvature. It curves in this direction and it curves in this direction. And the top blade here is different from this one and this one. And you need to use the surface modeling tools in CAD software to do this. But if you just want to clone the badge, not making the skin cover, in this case you can trim the car panel out. So you have to trim it as much as you can using your mouse and steady hand. Next you're gonna mesh them. After you mesh them, now you can fill the hole using this function, a hole filling. Click on manual, click on tangent. You can try between tangent, curvature and plane, but usually tangent will give the best result. Click on here. As you can see, it's not smooth. It's connected to the car panel. If you really want to scan and print, you need to remove the badge from the car and scan the back side. This is a cloud compare and align the point cloud. 1, 2, and 3. But this one has to go up, so I'm going to rotate along the Z-axis. This one is go up because I can mirror left and right, so I'm going to align this like this. Okay, click on check mark. Okay, here is in the Autodesk Inventor. I have already aligned the point cloud to the origin point. This is the y-axis. There are 3 fan blades. One on the left and on the right is symmetry. And this one here is different. If I show you here, you can see the one on the top, it has the symmetry curve. The fan blade on the left and right, it leans with some angle, same as the propeller. The only method that can be used to model this logo is by using a surface modeling. Autodesk Inventor, they have a surface tool called patch surface. So when you found the object that has dual curvature, like this one is curved, this plane is also curved, but it has to be modeled with the surface modeling tools. To be able to create the patch surface, you need to make 3D lines, which I'm going to show you. Before I can start to make 3D lines, I will start with the 2D sketch first. I'm going to create a plane and move it down to the bottom here, create a sketch here, front view, and hide the plane. Next I'm going to create a line, just quick sketch. And I'm going to project y-axis for Miller. See here, it has a round corner. I'm not going to round it in a 2D sketch. It's going to add complication. I will use the fillet command later on. Miller line. Because I'm going to make a cover which is bigger, I'm planning to have wall thickness of 2 mm. So I'm going to offset the sketch by 2 mm. Next, I'm going to create another sketch on the top, because you can see here, the upper edge here, it has a different profiles. And I'm going to move it up here, create another sketch, and start to trace the line. Okay, one thing you can notice with the high precision 3D scanner, when you mirror the line to the opposite side, it will match. I need to offset this for 2 mm for the wall thickness. Next, I'm going to create the height reference 3D lines to about here. Give a dimension, and I'm gonna do the same for the outer shell here. Because of the shell thickness will be 2 mm, so I'm going to offset it by 2 minus 2. So this line will be shorter than this line by 2 mm. Minus 2. Okay, same here. Now I'm going to create arc 3D outlines. This will be the profiles. Okay, it may look complicated. This example is not easy. I told you this Mitsubishi logo is not easy to model. I'm going to demonstrate doing a patch surface. So to be able to do the patch surface, you need to have a closed loop line. So this will be the first patch. Keep doing it. Okay, this will be the second patch. This will be the third one. Fourth one. Okay, this will be the offset surface of the cover. Okay, for the second sketch, I do the same. I use the 3D line. I locate the height. It's a bit difficult to do because the model it has been filleted, or the corner has been filleted, so it's quite difficult to find the edge. But it is possible to do because you can always adjust the height later. This time I'm gonna use the same height. Okay, I'm gonna do the same for all of this. Okay, next I'm going to do the patch surface. Okay, next I'm going to close the bottom edge here. Okay, so now I have a watertight surface. If I use stitch command, it's going to convert this into solid. Now I have solid. Next I'm going to do fillet. Let's try 2mm. Now I have fillet. Next I'm going to do a fillet here, but this time I will use variable radius fillet. In the bottom is 2, on the top will be 1. I'm going to do it here, variable. This one is 2, so the radius is different. Next I'm going to do a fillet here along the edge about 0.8. Let's try 0.8. Okay, 0.8 looks good. Okay, next I'm going to make it hollow with the wall thickness. That's supposed to be 2mm, but I need some clearance for adhesive, so I will use 1.8 for the wall thickness. We'll click on shell command. So it's gonna ask for the wall thickness. I'm gonna input 1.8 and remove this face. Okay, now I have a 1.8mm wall thickness, and you can see that the point cloud is not touching the solid. There's some gap right here. You can see the gap. Okay, next I'm gonna save it as a STL file because I'm gonna print this with the resin printer. The sheet to block, it doesn't work very well with the step file, so I need to export this as a STL file. And I don't think that I can print this with the FDM printer. Okay, this is sheet to box Pro version. Click on automatic orientation. This function is very good. Back in the day that I used it in 2022, it didn't have this function. Okay, next I'm going to click on support, auto support. Click on apply. I use adaptive support slice. You can see the layer that is going to be print. They have this function, detect Iceland, cannot detect any error, network sending. Okay, so the printer is idle. Okay, select the printer, click on send. It's best to print with the ABS like resin, but I don't have it, so it's got to be a hyperfine resin that used for printing a miniature. Close the lid so the smell won't come out. I don't know why it's showing this, but it's still printing. Okay, so it's look okay. So that was a false alarm. Okay, here's the printing result. It looks just like a injection mold plastic part. I think I can make it thinner than this. This one is 1.8 millimeters for the wall thickness. I think 1 millimeter would be just fine. And you can see that there is some mark from removing the support. For the resin printer, it's going to show us a small dot lines. You can fix this by dropping the resin with a Q-tip and use a UV flashlight to harden it and sand it. But I'm not going to do that here. It's already look good even when the support is removed. First, when I print this, I click on the automatic orientation on the sheet to box slicer and it works very well. Now the software can optimize for the orientation of the print and reduce the risk of the print failure, that it will fall out from the print bed or the support. It's much better than printing with the FDM printer. For a part like this, you're gonna need a resin printer, and you can see here it will fit to the curve of the car panel. Okay, let's do the test fitting. It's only go in one way. This one will not fit, so it has to match the curve of the car. If I turn it on this side, it will not fit. You can see here it has to be this side because the fan blade it doesn't have the same shape. I'm gonna put the double side adhesive on this badge. Okay, now it should fit. I think a black color would be better, but I don't have a black resin. Thanks you guys for watching. I'll see you in the next video.